Hey guys, welcome back to the C++ series. In this video, I'm going to explain what functions are, why we need them, and how to use them. So, when you write any kind of application, it happens very often that you have a piece of code to perform some task and then you need that same piece of code at multiple places. For example, let's say you have copied some code at 100 different places. And after copying, you realize that there was some problem in that code and you need to modify it to fix the problem. This means that you will now have to make the same fix at all the 100 places too. Although this is doable, it will be time consuming. And this is why it is generally not a good idea to duplicate code. To solve this problem, we have functions. A function is a reusable block of code that you can write once and use at multiple places. The general syntax of a function is like this. You first write the return type of the function, followed by the name of that function. Function naming rules are similar to variable naming rules. And after function name, you have a set of brackets enclosing the arguments to this function. You can think of arguments as input to this function. And finally, you have the body of the function inside curly brackets. For example, let's create a simple function. This function will not return anything, so I'll write its return type as void. Let's name this function as print. I'll keep the argument list for this function empty as this is a very simple function. And finally, inside the body of this function, let's print hi. So this completes the definition of this function. Now let's see how to use it. For that, I'll first remove this stdcout statement from main. And then I'll write name of the function followed by the empty argument list inside brackets. And then a semicolon at the end. This is how you call a function. If I build and run this, you can see that we get the hi message printing in the console. So basically what happens is when you call a function directly or indirectly from main function, the program execution goes to that function and executes its body. In this case, it means when we call print in main function, the execution goes to body of print function, prints hi, and then comes back to main function. Now let's see how we can control the output of a function by passing some arguments to it. So here I'll add one argument of type float and I'll name this one as x. And then in the body of this function, let's print x to console. As we now have modified the print function to take an argument of type float, all the callers of this function will have to provide that input. So I'll pass in 54 as input to this print function. Now when I build and run this, you can see that this function now prints 54 which we passed to it when we called it. You can have as many arguments as you want in a function. So let's see one more example for addition of two floating point numbers. So in this case, as the function is going to return sum of two floats, the return type of the function will be a float. Let's name this one as add. Add will have two parameters. And these will be the two numbers that we want to add. And inside the body, we will just return a plus b. If you want, you can store the answer in another variable and then return the variable instead. To test this, let's create two variables, int x is equal to 10 and int y is equal to 5. Now to get the sum of these two numbers, we can write add x, y. This means value of x will be copied to a and value of y will be copied to b. Let's store the return from this function call in a new float variable called sum. And to see the answer, I'll just print it out to the screen. If I build and run this, you can see that it says sum of 10 and 5 is 15, which is correct. So in this way, you can add any two numbers by calling add and passing in those two numbers. All this is good till you want to return a single output. But let's say you want to add two vectors. And for simplicity, let's assume that these are two-dimensional vectors. As a result of addition of two vectors will be another vector which will have a x component and a y component. We cannot have a single return. So we cannot return float here. So I'll make the return type of this function as void. Let's name this function as add vector. And to get the input vectors, I'll add 4 arguments. First two will take x and y component of first vector and next two will take x and y component of second vector. And then I'll add 2 more arguments representing x and y components of output vector. Now in the body we can simply write x is equal to x1 plus x2 and y is equal to y1 plus y2. So now in the main function we can have float x1 is equal to 4.5, float y1 is equal to 5, float x2 is equal to 6.5 and float y2 is equal to 8. And for the output vector I'll create float x is equal to 0 and float y is equal to 0. And now we can call add vector by passing in all these variables. Now to print out these vectors, I'll quickly make a new function called print vector, which will just print the input x and y values with brackets and comma in between them. And then I'll call this print vector 3 times to print input vectors and the output vector. If I build and run this, you can see that first 2 vectors are printed properly, but the output vector is still 0, 0. This is because when we pass a variable to a function, that function creates a local copy of that variable. So the last 2 arguments that we modified inside the body of add vector are not the same variables as the ones we passed in when we called add vector. This means any changes done to local variables in a function does not affect the original variables. If you want to pass in the original variables to a function and have them modified, you can pass them by reference. This can be done by adding an ampersand sign after the data type of that variable, like this. And now if I build and run this again, we get the third vector as 11, 13, which is correct. So it is always a good idea to pass arguments to a function by reference. This avoids unnecessary copies. But then it introduces the risk of variables getting modified accidentally. To avoid that, you can mark a variable as const by adding const before the data type of that variable. This will ensure that no copies of variable are created and only variables marked as non-const get modified. For example, in print vector, if I try to change the value of x, which is passed in as const reference, I'll get an compile time error saying assignment of read-only reference x, which means we cannot change value of an input argument marked as const. So that was all for this video. There are a lot more things to cover for functions, which we will discuss in the next video. If you liked this one, make sure to hit that like button and maybe also consider subscribing this channel for more such content. I'll hope to see you in the next one.